Okay. How y'all doing on this fine Vienna day? I live in Seattle, and it's actually quite rare that I wake up in the morning, look out the window, and miss my home. I mean, don't get me wrong, I miss my wife, but it's rare to look out the window and go, oh yeah, it looks just like home. Thanks for that, just so you know. All right, how many of you have done Scala before in any capacity? Okay, probably looks like about a dozen of you. You may be bored, just letting you know. That last word there, basics, that's really serious. I mean that quite literally. We're going to talk a lot about the Scala basics. We're getting some very, very fundamental things out of the way, largely so that you can take what you get out of here and go learn more stuff about Scala. It's intended to be something of a teaser. And let me be really, really, really clear. No, you may not put Scala on your resume after this session. Okay? I know you were all coming here hoping to be able to say professional Scala developers, because then you can go do big data and you can go make all kinds of money, and the women will flock to you, the men will be amazed by you, you will trip over the stairs, etc. My name is Ted Neward, but you don't care about me, you care about Scala. So let's get going. What I want to do is I want to get some very basic syntax under your belt, get you some exposure to the Scala type system, let you see some of the identifiers, lack thereof, talk to you a little bit about how to run Scala, etc., etc. Basics, just getting you up and going with the language, okay? First of all, it is a fundamental rule that whenever you are learning a new programming language, you must write hello world. Otherwise, the gods of computer science, they are angry with you, and your code will never compile correctly. So, having appeased the gods of computer science, what do you notice about that code? Just shout it out. I'm an American. Interrupt me. That's what most of the other Americans do. What do you notice? There's an arrow in there. Yeah, we'll talk about that. And it's interesting because that arrow is kind of facing the wrong way, isn't it? That's okay. It's legit. We'll talk about what that means in a little bit. You can sort of assume that we're walking across the collection of args and putting each one into S. We'll talk what that means in more detail in a few slides. But what else do you notice? No main. Yeah, Scala actually has two basic flavors. One is to use it kind of like a strongly typed Ruby in interpreted fashion, so we can save this off as hello.scala, and then we can just run it directly. You can also fire up Scala as a REPL. Just hit Scala, hit return, and you've got an interactive environment. That's cool. What else? No semicolons. It's so much fun in Java. Have you ever noticed in Java, by the way, when you leave out a semicolon, the Java compiler not only points out the fact that you left out a semicolon, but it uses ASCII art to point to exactly the right spot in the code. Seriously, they do a little caret on the next line, and then a line over here, and then they say, did you forget to put a semicolon here? Okay, if you know what I did wrong, and you know where I did it wrong, and you point it out, but actually fail to just go past it, you're just being a dick. I'm sorry. That's just the Java compiler insisting that, the bowl of M&Ms cannot have any green ones, or I just simply won't compile. Scala's part of this group of languages that have emerged over the last decade that says, look, the semicolon as a statement terminator, it's kind of served its purpose. That the semicolon is so 1995. Let's kind of go past that. You can still use it, and there are a few very edge cases where you may choose to use it. But for the most part, the Scala compiler will recognize the carriage return line feed as a statement terminator and just do the right thing. So for the most part, they are completely optional and unnecessary. Idiomatically, the Scala community seems to prefer a lot of code that does not have it, but you will find a lot of Scala developers who just, for whatever reason, their fingers are hardwired, that they just have to hit that semicolon before they hit the return key. And nobody in the Scala community is going to laugh at you for being unable to break that habit. It's okay. Some of us still think in objects too. A couple other things to bear in mind too, however. First of all, notice that we have everybody's favorite system there still. System.out.println. That is plain old Java. The Scala environment has complete access to the entirety of the JVM, so everything that you know already about Java applies equally well to Scala. That's actually one of the important things of running on top of the JVM. The other thing to note is that the Scala syntax in many respects is going to be similar to what we see in Java, but it's not identical. And as a matter of fact, in some cases it is deceptively close and can actually lead you to make erroneous conclusions. So bear that in mind as we look through some of this stuff, that it may look like it behaves the same as it does in Java, but in some cases there are some subtleties that you really want to know, and I will try to call them out as we go. What do you notice? Dude, it's an if-else. How much can there really be here to notice? No braces. Well, that's just because I'm trying to fit it all on one slide and I'm being, lazy. You really should have braces there, but that actually masks a deeper point, a more important point. Look at the second block. You see where I say val message equals if else? Yeah, if else is not a statement, it is an expression. For those who aren't sure of the difference between those two in English, statement implies it's just a statement, right? Donald Trump is a buffoon. That's a statement, all right? An expression, on the other hand, yields a value, okay? So when we talk about in programming the difference between a statement and an expression, in Java, the if-else is a statement, whereas the ternary operator, the question mark colon operator, that is an expression. It always yields a value. And as a result, this leads to a couple of things about Scala's if-else. First of all, there must always be an else, because if this thing is going to yield a value, then it has to be able to yield a value in either case, because the absence of a value is not really a value. At least that's the way Scala envisions it in this particular scenario. So here in the top block, we throw away the value that's returned from that if-else, which in this case, system.out.println, that returns the Scala equivalent of void. So there's kind of no value there, that's okay. But in the bottom, you can see specifically, if args.length is greater than 0, we yield the string, we got arguments. Otherwise, we yield the string, nope, no arguments. Whatever we yield, that gets bound to the local value message, which we can then use in the system.out.println that follows. Now, a couple other things to notice about this while we're going. First of all, the if-else here, if if-else is always going to yield a value, then we need to understand what the type of that value will be. This is where you get into one of those cases where what looks good and works well in Java will not do so in Scala. If, for example, if args length, we got arguments, else 12, for whatever reason, now you've got an if-else where one branch is yielding a string, the other branch is yielding an int, and the Scala compiler can't reconcile those two. And it'll give you an error saying, hey, this else branch is supposed to yield a string, but instead it's returning an integer. If you think about it from Java perspective, which says if else is a statement, then what should it matter? But because this is always yielding a value, it's an expression, the return type of that expression, the value yielded from that expression must be the same in both cases. Okay? So for the most part, when you start working with if else, make sure that A, it's yielding a value, and B, it's yielding the same type of value. Another thing to note about this, what type is message? String. It's most definitely a string. Now, where do I say that in my code? It's inferred. I don't have to say it because, in fact, the Scala compiler is a very, very smart creature. As a matter of fact, in many cases, it's smarter than the programmers using it. Okay? This is a direct contradiction to the Java compiler, where you have to tell it everything. You have to tell it exactly the type of every variable you work with. You have to tell it the type of every parameter you describe. You have to tell it the type when you're getting something back in terms of a downcast. The Scala compiler, because this is all strongly typed, it's much more strongly typed than what we see in Java. And as a result, the Scala compiler can frequently, not always, there are places where it'll get confused, but it can frequently figure out what the type of this thing is supposed to be and therefore apply that descriptor. So in this particular case, message, since the return from the if-else block here is clearly of type string, those are string literals, messages of type string, and well, when we type check that with println, it all works. Yay, everybody's happy. Okay, so the compiler is figuring this stuff out as it goes. Now there are limits to its scope. There are going to be places where the Scala compiler simply says, "Hey, I don't know what this could possibly be," so therefore you'll have to provide type descriptors. We'll see those in a little bit. But the other thing that's important to know, although you can't really infer it from the code, is that val is immutable. There are two types of locals when we start talking about Scala. There are vals and there are vars. Val, value, var, variable. If you're going to be a good Scala programmer, you're going to prefer vals over vars. You're only going to go to a var when you absolutely have to. Again, just like semicolons, mutable state is so 1995. Begin to stop using it wherever you possibly can. When I first started exploring Scala, gosh, I guess it's been almost a decade ago now, that was one of those things that I kind of figured, yeah, everybody talks about being able to do that, but how easy is it in real life? How hard would it really be? When you start going back and looking at all of the various Java and C# and other code that you've written over the last decade, it turns out that it's probably about an 80-20 rule. 20% of the code that you write, you're actually modifying a variable over and over again inside of a given method. Most of the time we declare it, we use it, and it's done. It's actually not being mutated. Now, maybe that's just my stylistic. Maybe other people prefer to reuse the same variables so that we minimize the number of declared locals. I actually worked with a guy once who declared one local variable of type object and then used it 12 times inside a single method. And, oh, it was great. It was just that one local variable, but yeah, he didn't survive the purge. Anyway. Point is, it's actually a lot easier to get on board with this immutable state thing, particularly when you've got a compiler that will help you discover when you actually try to do something that's mutable. And there are a number of cases where you can simply introduce a new local. Val string 2 equals string 1 plus whatever modification you want to make. That's actually a very, very common idiom in Scala and other functional languages. All right, what do we see here? This is more of that backwards arrow thing. This is a series of 4 loops. And in the very top block, we see essentially the equivalent of what we saw before. We simply want to loop over the constructs in a collection. In this case, args is the implicit array of arguments that's passed into this script from the outside. Those are your command line arguments. And here, we're going to go through that loop. We're going to bind each one to A, and then we're going to println it. Okay? Now, quick note, where did println come from? Well, as it turns out, you see the import statement on the line above, import system.out._. That's kind of like a static import, but it's actually a static and a member import. So at this point, all of the symbols that are available on system.out are now accessible at the top level. So we can just use println as a shorthand for system.out.println. This is actually very, very common in Scala. And as a matter of fact, imports can be nested. So in fact, I can do an import inside of a method or inside of a class in order to scope the visibility of the particular symbol that's being imported. Here, since it's at the top of the file, it will be visible throughout the entirety of the file. But if I have a class and then I have a method and then I want to work with some particular element, I'll import it there, use it, and then be done with it. And that way you avoid some of the clashing names that occasionally comes up when you try to import across a large number of packages. But you notice for args, that seems pretty straightforward. And you can kind of understand why the arrow is pointing the other direction. We're going to take each element out of args and we're going to put it into A. So that's kind of traversing from right to left there. This is actually not a for loop. This is what they call a for comprehension. Because functional guys, they love to sound pretentious. It's not a loop, it's a comprehension. You uncultured cad. You have to smoke a pipe, by the way. Wear a jacket with patches on the elbows. The second one is definitely a different beast. It looks basically like a traditional for loop for I equals 1, I is less than 3, et cetera, and that's basically how it's going to behave. But we've got two of them separated by a semicolon. So this is part of the reason why we needed to save all those semicolons off the end of our statements, because we're going to use them in other places, right? The law of semicolon management must be obeyed. So here, what we're actually going to do, you can think of this in Java terms as being two nested for loops. But essentially, a for comprehension can consist of a number of one of two different things, either a generator, which is creating the things that will be bound against, or a filter, figuring out whether a particular condition is met and therefore allowing the rest of the comprehension to be executed. And here we see two generators, 1 to 3, 1 to 3, each being bound to I and j respectively. The further to the right inside the parentheses we are, or further down, depending on how you format your code, that's going to be the innermost one. So here, j will get bound 1, 2, and 3, and then I will be bound 2, and then j will be bound 1, 2, and 3, and then I will be bound 3, and then j will be bound 1, 2, and 3, and then we're done. Pretty straightforward, right? The bottom one is where we really show off generators and filters. Now, essentially, what we're doing here is we're standing up a pipeline. We're saying, first of all, I will get bound the value 1, because that's the start of that first generator. The next is a filter. And again, remember, this is basically a Boolean test to determine whether or not this particular expression matches. So is I modulo 2 equal to 0? Well, 1 modulo 2, that doesn't equal 0, right? So we immediately bounce back to I and get bound 2. So this is, you can sort of imagine in your head how this would look. It would have to be a for loop followed by an if test followed by a continue. But we're doing it, I doing a filter, j doing a filter, then the two of them multiplied modulo 2. By the way, this algorithm didn't do anything. It was just an example, so don't try to figure out what I'm trying to accomplish. Occasionally when you write a demo, creativity fails you and you're like, screw it, I'm just going to do some stupid math and call it a day. But this is demonstrating the fact that we're going to have 2 generators, 3 filters before we get to this final block here, which is just doing a simple series of print statements. These are not for loops. These are for comprehensions. And, by the way, do you see that 2, 1 to 3, 1 to 3, 1 to 6, 1 to 6, etc.? That's not a keyword. We'll talk about that in a little bit, but that's not a keyword. That's actually a method. And I think I described all of that. Speaking of methods, functions, depending on how you want to use the term, here we're defining 2 functions, a print and a print, one taking a string and one taking an int. Now this is one of those cases where providing type descriptors will be important. The Scala language has its limits. It can't look across the entirety of the world to figure out how this thing might be used in code that hasn't been written yet. So some languages, some functional languages will actually try to do type inference across modules. Scala punts. Scala says, look, if you're going to define functions, if you're going to define methods, for the most part, I'm going to require a type suffix. Now, if the method use is somehow encapsulated entirely to this file, you can sometimes get away with it. But for the most part, it's better to assume that you're going to have to provide a type descriptor when you write a function or when you write a method. And the only difference, by the way, function versus method, function is not associated with any particular object. Methods belong on objects, be they static or instance. You'll notice that the syntax here is name colon type, Pascal style typing. The reason for that is very, very simple. Makes it easy on the parser. As the parser is reading through this, if it sees a name, an identifier, it can assume it's an identifier. If it sees a colon, it knows what will follow will be a type. This Pascal style type notation is something we see a lot in a lot of different functional languages. Haskell uses it, F# uses it, OCaml uses it, ML uses it. It's pretty much a standard thing across all these different functional languages. So if you don't like Pascal style typing, you probably want to go back to Groovy or whatever dynamic language you crawled away from. You can see using print here. You can see down below if args length arg0, else from Scala. Again, that's going to yield a string. Now you'll notice as well, count2 here, it has a nested function. This is actually a very powerful encapsulation technique because in this particular case, we are defining a function that we will invoke recursively as a part of this count2 method. But this count method will never be accessible to anybody outside the scope of count2. It is effectively encapsulated away from anybody else who might want to use it, including other functions or methods inside this class. Okay? You'll also notice the use of recursion here. That's a very, very common thing in a lot of functional languages, to recurse divine, to iterate human, to recurse divine. That's the full expression there. The other thing you'll notice is that count, the nested method here, has an explicit return type described that we don't see on any of the other functions. Again, Scala will try to infer the types. And in this particular case, Scala is able to successfully infer the types, the return values of print up there at the top, because the last expression in that statement, in that block of code, system.out.println, that yields void. Well, the thing about functional languages is they don't really like void. Functional languages, functions, anybody who's ever spent any amount of time doing math, how many people here graduated from grade school? Show of hands? Yeah, the people who aren't putting their hands up are just, they're asleep. When you did mathematics in grade school, right, functions yield values. 2 + 2 equals box, and you had to write 4 in crayon, right? Unless you're from the deep south in the United States, and then you write Jesus. Functions yield values. Void is a complete absence of value. These two things do not go well together. As a result, the functional community basically decided to come up with a value that represents no value, and they call it unit. And like Boolean, which has two literals, true and false, unit has one literal, parens, parens. Okay? So here where we see count, count takes an I of type int, and count yields unit, meaning count doesn't return any particular value. Well, no, that's not technically true. What count returns is the value unit. It returns the singleton literal unit. The same is true of print up there at the top, but that's because the Java binding, system.out.println, that returns void, and Scala simply says, well, void in the Java world is equivalent to unit in my world. This is how they get around the idea that everything yields a value. They simply say, all right, well, if you need to not yield a value, you can yield unit. And that's the moral equivalent to void, but it is still a value. Kind of like null. functional guys don't like nulls, so we call it unit instead. See, everybody's happy. By the way, interesting bit of trivia, the guy who invented null has apologized. No, I'm serious. Sir Tony Hoare, Hoare, was knighted for his contributions to computer science. He's the guy who invented null. And at a speech given to the ACM, the Association of Computing Machinery, some fancy awards dinner where they were giving him even more titles, or, you're now a fellow of the ACM or whatever it was, he stood up and basically apologized to computing science as a whole, saying, I consider nulls to be my $1 million mistake. Based on the amount of null pointer exceptions I've gotten in my code over the years, I think he's letting himself off easy. I think it's more like $1 billion mistake, if you ask me, with a B. One guy laughed. One guy has watched Austin Powers. I'm disappointed with all of you. A couple things to note. Def creates a new function, all right? For the most part, def, val, and var, you can sort of get away with a variety of interchangeability here, but for the most part, idiomatically, def means you're defining a function, val and var means you're creating a value or a variable, all right? Scala, like most other functional languages, will let you take a function literal and use it as a value, so you can create val, add, equals, and then define a function here. But for the most part, idiomatically, we prefer def for defining a block of code that is to be executed, and val and var to represent specific values, okay? Excuse me. And I think I did all the rest. Okay. Again, more about imports. Remember I said imports can, bring in all of the symbols on a particular object like we did with system.out, right? So we brought in all of the println on out as a top-level member. Import can do more than that. First of all, as I said, import does not have to be at the top of the file. Import can appear in the middle of a file. It could even appear in the middle of count2 if I really wanted it to. And it's only in scope from the point it appears on downwards until that scope expires. Here, it'll be in scope once the import java.math big integer, and I'll talk about that in a second. Java math big integer is only in scope from that line further down. Okay, until this scope, which happens to be the global scope, runs out. The other thing is you notice the curly braces there. That is a name alias because I decided that big integer is just too long to type. See, I used to be a C++ programmer. And C++ programmers, your manliness is measured in how much code you can write in the fewest number of keystrokes. Which is why if we had our way, C++ code would all be written on one line. Seriously, you don't believe me? Go read some C++ code, people. They want it all on one line if they can help it. I don't like big integer. I just don't. I just don't like it. It's too long of a name. I want it to feel more like a primitive type if I can help it. So I'm going to rename it to bint. Sort of like uint means unsigned integer, bint means big integer. Makes total sense, right? It's a bint. So then I can use bint anywhere that big integer would be expected. It's just simply a name alias. But this actually is an incredibly simple, useful feature because it really helps avoid with a lot of the import name clashes that would otherwise show up inside of code. It also allows me in some cases to better express what I mean by particular things. So here I can say import Java math big integer to bint, great, and then import bint dot underscore. Here I'm using that name I just created to import all of the top level symbols on big integer. Then down below, now instead of counting to n where n is an int, n is now a bint, and you can see I use the methods on bint if I.min n, taking the minimum of that. But then notice in the last lines here, count I add 1, count 1. 1 is a symbol defined as a static constant on the big integer class. Because I've imported big integer dot star, that means that it's accessible as a top level symbol. The other thing that's important to note about Scala is that in certain cases, dots and parentheses for method invocation are optional. The compiler is smarter than you. The compiler can look at the identifiers in question and say, well, what if there was a dot here? And what if there were parentheses here? Would this compile? And if the answer is yes, then it does. This is part of the reason why Scala is routinely held up as one of the languages for which it is the easiest to write an internal DSL. Internal DSL meaning I don't create a specific language parser and interpreter. I simply use the language features as they are given to me in order to create something that doesn't really look like that language. So here, I add 1 is specifically invoking the add method on I, passing in the big integer constant 1. Make sense? This also explains the 2 we saw earlier. 1, 2, 3. The 1 is actually an integer object, and integer objects have a method on them called 2, which takes a parameter, which is another integer, and the result of that is a range object, which is effectively a collection. And so now I can walk through that collection consisting of 1, 2, and 3.
So in this example, if someone implemented a print line method for a big integer, this method would be broken.
If somebody implemented a println for big integer, this method would be broken? Is that what you're asking? Why would it be broken?
So how do you know that the print line is for system out?
How do I know the println is for system out? You mean here in the count method? And I know that because I imported system.out._ up top, right? So all the symbols that are available on system.out will show up. And here, again, the Scala compiler is smarter than you. That doesn't mean it's perfect, right? If I've imported other packages that include a println top-level symbol, yes, I've introduced ambiguity, and therefore Scala will require some sort of resolution. I mean, the same is true in any given language, right? But again, remember I can nest imports if necessary. So if I have some other package that creates its own println method that takes a big integer, well, as long as it doesn't conflict with any of the printlns from system.out, println here only works because a big integer is an object, right? But if I have a better match from a separate package, well then cool, I'll just use that and there's no ambiguity. Does that make sense? Meh. That was not really enthusiastic there, my friends. He's still thinking about it. All right, we'll come back. You can accost me after the talk, and I can show you. We can work up a quick example, and I can prove it to you.
It's okay.
No, it's not. It's not okay. Now you have challenged my man. Okay, fine. We'll move on. Actually, he looks bigger than me. Never mind. You win, man. You win. All right. What is this? Certainly from looking at the code, it has this word called array, but that doesn't look like any array I've ever seen. How about you guys? It's a sequence. No, actually, it's an array. It's an actual array. Nice try, though. It is an actual array. See, here's the funny thing about Scala. On the one hand, Scala wants to compile to the JVM, and it wants to take advantage of all of the primitive types and all of the optimizations that the JVM has made available over the years. And let's be really clear about things. The only reason Java has arrays is because C++ programmers are a bunch of whiny children. Because when Java first came out in 1995, 1994 timeframe, one of the explicit goals was to create a language that was attractive to C++ developers. And one of the principal concerns that C++ guys have is performance. It must run fast. I don't care if it takes 27 days to write Hello World, it must run fast. Those of you who were alive back then, you remember all of the discussions about how C++ was closer to the metal, right? You can get better horsepower, and JIT compilation and garbage collection will never be able to perform well. And oh, how we laugh at those arguments today, right? But at the time, Java was very, very concerned about how it would be viewed. So they introduced the array as a part of that eye towards performance. And as a result, the array has very, very different syntax and semantics from any other collection inside of Java, which creates inconsistency. And this is one of the things that Martin Odersky, the creator of Scala, really wanted to try to eliminate, was inconsistency throughout the language. Wherever possible, he wanted to make things extremely consistent. So as a result, to instantiate an array, just as you would with any other collection, you use a constructor-style syntax. This will create an array of 4 elements, 1, 2, 3, and 4. But it looks the same if I want to create an instance of a list, or if I want to create an instance of some other collection that takes a sequence of values. It looks the same if I want to create a range, for example. The intent here is very clear. Make it all consistent. Now, the concern that a lot of Java programmers will have, because they used to be C++ programmers, and therefore they're still sort of concerned about performance, is, well, if I'm calling a constructor here, that's going to be slower than if I just do the new brackets syntactic style that I'm used to from Java. Dude, the Scala compiler is smarter than you. It knows to translate that into the exact same sequence of opcodes that the Java code would generate. Trust the compiler. This is one of the key things that you will have to learn to do as a Scala developer, is trust the compiler. Partly because the compiler is smarter than you, partly because in a functional language, we vastly prefer compile time errors over runtime errors. So the compiler is going to be much more aggressive about preventing certain kinds of things. It's going to be much more verbose about telling you when something doesn't work. And if there's one thing that's wrong with the Scala compiler, it's that the errors are sometimes incomprehensible. In which case, you simply look at the compiler output, realize compiler says, ouch, line number 47. Go fiddle with line 47 until it compiles and then move on. That was supposed to be a joke. Anyway, as you can see, we access the elements of the array using the rounded brackets as opposed to the square ones. Again, that's in the interests of consistency, so it looks the same across all the different collection classes. And you'll notice I can also assign using the rounded brackets, right? Again, it's all going to turn into the same code under the hood once the compiler's done with it. So this is how we use a Scala array, okay? By the way, just like in Java, arrays are immutable, right? So once the array has been initialized, it's 4 cells, therefore it's 4 cells, and it remains 4 cells. If you want something that's mutable, there is a set of mutable collection classes in the Scala library. But for the most part, again, we prefer immutability, and that's where the arrays fall down, is the contents are not immutable. As you saw, we can change them there in that second to last line. I can change the contents of an array. For the most part, we prefer collections where they are not mutable, even to the contents themselves. I mentioned, by the way, the notion of recursion. Recursion is a very, very big thing inside of functional languages, largely because recursion encourages immutable state. See here, one of the classic examples that you will see in any functional language, the functional equivalent of hello world is factorial. Okay, just if you start diving into Haskell, F#, OCaml, ML, any of these functional languages, the very first thing they will show you is factorial. Okay? And it will recurse, guaranteed. Because as it turns out, most of these functional languages can engage in some compiler trickery known as tail recursion optimization. If the recursing statement is the last thing that is evaluated, we take the result of the recursion and hand it back as the result from this expression, then it can actually optimize away the various calls through. So that this, even if I want to do factorial of 10 million, if tail recursion optimization can be applied, I don't need a stack 10 million elements deep. It can all happen inside of one stack frame through, quite frankly, judicious use of some for loops and or a goto. All of that is compiler trickery. The other thing that we prefer about recursion, though, is that any interim state is held on the stack, which by definition is thread safe. So therefore, all of this code is intrinsically thread safe, and its accumulating equivalent may not be, depending upon if multiple threads call in at the same time, et cetera, et cetera. For a simple example like factorial, it doesn't really demonstrate itself well, but in other cases, it becomes much easier to see. It's much more visible. And again, we see the use of the big integer symbols used without their prefixing big integer dot. And n multiply factorial parens n subtract 1. The parens there are necessary because Scala would get confused if that were all on one line with no parentheses. We want to invoke the subtract 1 before we pass it to factorial, before we multiply it against n. Other than that, though, Scala understands completely what exactly we're trying to invoke and what exactly we're trying to pass. All right. Now, I mentioned arrays. One of the things that functional languages will tell you is that arrays are evil, stop using them. They prefer lists instead. Lists are intrinsically immutable. Both the, I should say, the list is immutable from the standpoint that the contents are immutable. The list itself is actually also immutable, but we can still do various things with the list. Thanks to its immutability, it actually turns out to be fairly optimized operations. So here, val numList equals 1, colon, colon, 2, colon, colon, 3, colon, colon, 4, colon, colon, nil. The colon, colon is, for historical reasons, referred to as the cons, C-O-N-S, cons operator. Okay? That actually goes all the way back to Lisp from the 1960s. And essentially, it's an append operation. So here, 1 is appending 2, is appending 3, is appending 4, is appending nil, meaning the end of the list. Okay? And so now I have a list of 4 elements in it. numList 2 is actually an empty list. Again, notice the constructor syntax. numList 3 is functionally equivalent to numList 1. Which style you prefer depends on how deep you've been in functional language arcana before now. If you are a Haskell programmer, if that's what you studied at university and that's what you believe God wrote the universe in, you vastly prefer the first form. If you're a Java developer who came to all this functional stuff late, you probably prefer the second form. And you know what? Who cares? They each work. As long as you can be able to read the other, everything holds just fine. Now you'll notice numList 4, numList 2 cons numList 3. We're consing the actual lists together. But notice up at the top, SumList X's is a list of int. Yes, ladies and gentlemen, that is a generic. And Scala guys chew them up for breakfast. Okay? There are lots of generics that will float around inside of your Scala code. As a matter of fact, if you ever really want to understand Java generics, spend some time in Scala, because Scala uses, it's not a bolt-on sort of added extra feature that Java guys can kind of sort of ignore. It's actually a fundamental part of the language. And you can try to shy away from it, but sooner or later you're going to have to figure out what covariant and contravariant types are. It's just part of being a part of this environment. Now, I'm not going to go through all that again. This is basics. But you're going to spend time learning about generics, and you'll find that once you do, once you've sort of mastered how all these things work, higher kinded types and so forth, coming back to Java generics is very, very easy. You begin to understand why some of that arcane stuff works the way that it does. So here, X is a list of int. We're yielding an int. Obviously, what we're going to intend to do here is we're going to sum all of the elements of the list, right? 1 plus 2 plus 3 plus 4. And again, you can see the recursion here. If X is empty, in other words, if the list is empty, then yield the value 0. Otherwise, pull off the head of the list and pass the remainder of the list, the tail of the list, recursively back into SumList. Now, this is actually a very, very efficient operation. In Java, it wouldn't be. If I were actually peeling off the tail of the list, chances are we would be creating a copy of that list and copying all the elements over. In Scala, because all of the list elements are immutable, we actually can just point to the second element of the list and pretend that's the head of the list. And as a result, this can be very, very efficient in terms of memory, space, and time, much more so than its Java equivalent would be, because the contents are immutable. Now, you'll notice the sum list down at the bottom there is commented out. It's because that actually wouldn't compile. Anybody want to harbor a guess why? Exactly, it's a list of lists. I'm not consing the elements of the lists, I'm consing the lists themselves as elements. It becomes essentially a two-dimensional set of lists, if you will. Okay? And that, by the way, is not a list of int, that is a list of int, which is a different creature entirely. All right.
What is this for a list? I guess is there something like Scala.lang.
Yes. There is the Scala dot package is implicitly part of every Scala program, just like java.lang is. And so the list type, the array type, all of these fundamental types, int, etc., they all come from that particular package.
How would they interoperate with the Java list, for example, if I have to follow?
So the Scala list has methods to convert it to a Java util list, but for the most part, you don't want to do that unless you absolutely have to. Because then at that point, the contents become mutable, it takes time to copy all the elements over, et cetera, et cetera. You lose a lot of the benefits of a Scala list. Over there on the side. The type is inferred, sort of. It actually becomes a list of any. Now, in this particular case, any happens to be a supertype, and it works. Don't ask me how. I'll be the first to admit, I don't understand all of the various ways the Scala compiler can do some of its inferences. And this is one of the dangers of Scala, is that occasionally code will compile and you don't know why. And you get surprising results. That's sometimes a good thing and sometimes not. Okay? For the most part, that's a rarity. Most of the time I have the opposite experience. I can see what I want to do here, Scala. Let me do it. Scala says, no, the types don't match. But they do. No, they don't. No, they don't. Okay, fine, they don't. Fine, I'll just cast everything to object and let's go from there, right? You fight with the compiler a little bit. And this is a good thing from the standpoint that the Scala compiler is actually trying to protect you from yourself, protect you from making stupid errors. But at the same time, it can be very frustrating. You really get to a point where you just want to find Martin Odersky and pummel him, right? No offense, Martin. I know you're going to view this recording later, but it's just compile, damn it. And this is one of the things that you just have to sort of understand. You know, if you're going to dive into this pool, you may as well dive in all the way. Spend the time to learn what the compiler message is telling you. And frequently, where these issues will come up is around the use of generics. Is a list of any considered an acceptable pass for a list of int? Or how is a list of any different from a list of object? Because there is an any type in Scala, and it is fundamentally different from the object type. Even though to a Java guy they would seem to be synonymous, to Scala they're really not. So this is part of what you're going to have to do as you get spun up on Scala is listen to the compiler, understand what it's telling you, because then you'll have far fewer compiler error messages. To be fair, the Scala compiler is much better about its error messages today than it was 10 years ago. 10 years ago, it was you really had to have a PhD in type theory to be able to understand these error messages. And Martin and the team have really gone to great lengths to make sure that it's something that people can understand. All right, moving on. Maps, name-value pairs. The arrow is simply a binding indicating that the key maps to the value, so the arrow goes to the right this time. Other than that, it's a map. Again, notice the constructor style syntax, the use of the plus here. This map, we're going to add this particular pairing, the Fred and 40 pairing. Notice the use of the plus plus operator. This will concatenate two maps together, okay? And then looking them up, we use the rounded brackets, just like we do with arrays. This is part of what I meant about consistency. You always use the rounded brackets to go look something up if that particular type allows you to look up by some kind of index, okay? And again, maps are intrinsically immutable and genericized. This map is specifically a string to integer map. Trying to put a string to float or an int to an int will yield a type error. Speaking of pairs, pairs are just a form of tuple. Scala has the tuple type as a baked-in type. And the tuple is actually one of these things I really, really want Java to get hold of before too long, because tuples are incredibly useful. Anybody here ever do any Java EE programming and did data transfer objects where you created a class that was basically a collection of public fields, but they couldn't be public because then your peers would laugh at you for having public fields, so you created getters and setters. And all this thing was a bundle of data that you wanted to hand across the wire from your servlet to your EJB server or back again or what have you. You remember doing that? Those are tuples. Tuples are essentially a simple bundle of fields, but in tuples, the fields aren't named. It's purely positional. Because most of the time, when we start creating these things, I don't care about the name of the thing. The position will be what's important. Now here, Ted Neward 38, string, string, int. The tuple type is string, string, int. It's not a person type. I happen to be using string, string, int to represent a person. The type is string, string, int. So if I have a function that's expecting string, string, int, it is perfectly legitimate to pass in Seattle, Washington, 5 million. If you need to differentiate based on some sort of naming, well, then you create a class. But tuples become incredibly useful, for example, yielding multiple return values. If I want to indicate that a particular query was an error as opposed to it simply yielded no rows, I can now yield a tuple of Boolean and int, indicating whether or not this query was successful, the Boolean, and the number of rows, the int. Tuples are used a lot throughout Scala. Get to know them. More importantly, we can also do, notice the val parens, first name, last name, age, close parens. This is known as structural decomposition. In other words, I can take a tuple and break it apart. In this case, since it's a 3-element tuple, I can break each of those elements and bind them into the local values, first name, last name, and age. Make sense? Okay. Shoot. Interesting question. Just for the recording, the question is, I look at first name, last name, and age. What the hell are they? How do I know? How do I, as a developer, know what those types are? And let me counter that with a question. Do you care? Do you really care? You do. Sure, you do. And as soon as you try to do something that you can't, I mean, you look at first name and you say, okay, well, first of all, if the name of the thing isn't an indication that it's a string, you probably need to stop writing C++ in Scala, dude. All right? That's the first thing. Name your variables better, right? But the second thing is, val first name, blah, 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 and you say, okay, I think this is a string, so I'm going to try to use this in a string way, and if it's not a string, what happens? Compiler will tell you. This is why. You got to remember, a lot of the functional community, what they will prefer to do, rather than do the edit compile thing that we're so used to from Java, they'll actually write the code in the REPL in an interactive environment where they can say, hey, first name dot tab, and they can see the moral equivalent of IntelliSense. Or they'll just say first name plus space plus last name, and it works, or it doesn't, and they say, that's odd. What is first name? First name dot class, and it says blah. You're like, oh, it's a blah, not a string. Oh, that's weird. Okay. And then what they'll do is they'll take that interactive session, they'll save it off, strip out the parts that don't matter anymore, and call that person.scala and compile it. It's a different way of approaching it. But the functional programmer will say, you shouldn't have to worry about the physical details of the code. You should be thinking higher. You should be thinking in a more abstract way, right? So you're not worried about ints and longs and floats and doubles. You just think about the business problem, man. You just think about the code, not the little niggling details of the code. This is very much a design principle that Martin espouses when he talks about Scala. So that's not me interpreting. That is literally what he was trying to do with the language. All right, moving on. Pattern matching. And this right here, guys, this is why you sat in this session. This is the moment. This is the money shot, as they say in Hollywood. Pattern matching. You could take away every other flow control construct away from me as long as you leave me pattern matching, and I will be a happy programmer. This needs to go into Java. Desperately. I've told Brian Getz this, and he sort of kind of agrees, as long as he doesn't break a bunch of other stuff. This desperately needs to go into Java. Here we see sum list again, right? Taking a list of int. But notice what I'm doing here. X's match curly brace. So on the surface, it kind of looks like switch. And it kind of is, in the same way that a kitten is kind of like a T-Rex. Okay? Because here, notice, the first case is case list parens, meaning if it's an empty list, then we yield the value 0. Because a pattern match always yields a value. Always, always, always. Okay? What that means, by the way, is the pattern match must be exhaustive. There must be a possibility, there must be a value that's yielded for all of the possible branches through the pattern match. And the compiler will tell you if you've left some out. Okay? We'll see how to address that in a second. Here it's exhaustive because then you'll notice case x : x's. Remember in the previous slide we were talking about structural decomposition? How you could take a tuple and break it apart. Turns out I can do that with pattern matching as well. But because it's so common to do this with lists, I can actually decompose the head and the tail as part of the case. So here, x gets bound to the head of the list, x's gets bound to the tail of the list, and then I use them, x plus recursively invokes sum list with the tail. Now, in of itself, you look at this and you go, okay, great, for when I want to add up lists, this is great, that's fun. But it's much more than this. Because in addition to being able, because think about what I did in that first example. I tested the contents of the list, as well as extracted the values and then used them. But I can do this across a variety of things. So here, notice O is of any type. Okay? That means it can literally be anything that could be possibly passed in here. So in the first case, I say, hey, if this is a 3-argument tuple, and by the way, I don't necessarily care what those types are as long as they can resolve to something that can be appended as part of a string, which means they probably need to be a string or have a 2-string. First name, last name, age, that's probably a string int, but you know what? If it's string float, that works. If it's string character array float, that works. I don't care about the types anymore. That's one of the things that Scala wants to get you towards, is to a point where you don't care about the types because the compiler is making sure all the types work. The second case, is this a string? The third case, is this an int? Fourth case, is this a list of int? This will actually generate a warning, something about the possibilities of this being some other list type, if I remember correctly. But notice I do a pattern match inside of that to do this recursive breakdown as well. Lastly, case underscore arrow. I have no idea what you just gave me. The pattern match allows me to not only test the values, which is what switch case will do, but it also allows me to test the types. It also allows me to test a range of potential values. It allows me to extract the values as a part of that test. It's exceedingly powerful. And it's something, quite frankly, that like I said, I really want Java to get, because there's so much code that could be intrinsically simplified by using this pattern match construct. Now, I'm out of time, so I'm going to leave you with homework. Okay? First of all, step 1, write the classic Fibonacci, right? Just do, in case you don't remember Fibonacci from your grade school math, because some of you apparently didn't pass grade school math. Remember Fibonacci, a particular value x is equivalent to the previous value in the list and the previous value in the list. So Fibonacci of 3 is 2 plus 1, okay? And again, it's going to look something like this, but you'll have to replace the 0 with your particular implementation. The next thing I want you to do is, instead of just doing an int, return a list of integers indicating the Fibonacci sequence up to that particular point. All right? So instead of just returning 3, you would return the values 0, 1, 1, and 0, 1, and 1. Right? Yeah. There we go. 1, 1, 1, 1, 1, 2, 1, 1, 2, 3, et cetera, et cetera. Okay? So return the actual list of each of those values of Fibonacci up to the third element in the list. And again, you're going to start with that as a basis. The last is to experiment with tuples, because tuples are fun, and tuples are, again, one of those things that could very easily be added into Scala or added into Java without too much difficulty. I'm hoping for Java 10, crossing my fingers on that one. But essentially, the idea of we're going to have a tuple, a name, a date, and then a value, the number of students in the particular class. Okay, and it would look something like that. Okay. Now, there are solutions, but I'm not going to show them to you, because that would defeat the purpose of the homework. But they'll be in the slides. You can get them from the Voxxed Vienna website later. Any questions before I turn you loose to go grab snacks and get ready for beer and whatnot? Because beer is important. What's that? I did not mention case classes. Are you doing the session tomorrow? Oh, no, I did not mention case classes. There's a whole bunch of stuff I didn't mention. I didn't mention classes. Is that your session? Stand up. That's where you go for the advanced work, folks. He's like the graduate lecturer. I'm just the undergrad, okay? He gets paid a lot more. You can tell because he's got like a collared shirt on and a jacket, and I'm just T-shirt and jeans. And another question. You have a user group, a Scala user group in Vienna. What's it called? Vienna Scala user group. That's incredibly unoriginal, dude. I was expecting Scala Retzenkotzen or something, you know. But he's got a sticker on his laptop. And you know it's a good user group if they have stickers. You ever noticed how programmers are like small children, give us stickers, and we're like, yay, stickers for my laptop. Any other questions? Going once. Going twice. Oh, in the back. Why not integrate Scala with Java? That's a great idea. The only problem is one is owned by Oracle, the end. I mean, Oracle would have to acquire TypeSafe, who is now called Lightbend, because the Scala language is technically owned by Lightbend. Although technically it's open source, you get where I'm going with this. There's two groups that are involved here. And it's not impossible, right? For those of you who don't spend a whole lot of time watching what goes on in the .NET world, Microsoft just acquired Xamarin, which is the maker of a cross-compiler series of tools for using C# to develop for iOS and Android. That was actually a move that probably should have happened 3 or 4 years ago, because today it probably cost Microsoft a boatload of money more than it would have 3 or 4 years ago. Similarly, yeah, you could make the argument that Oracle should acquire Scala and just offer it as one of the languages. But speaking as somebody who spends a lot of time in the Microsoft world, where Microsoft has 4, 5, depending on how you count, different languages that compile for the .NET platform: C#, Visual Basic, F#, C++, CLI, JavaScript. Sometimes that creates more confusion than it does clarity. Oracle's not giving up Java. And if they acquired Scala, it would be, I would think, with an eye towards bringing the two languages together. And to a large degree, we are seeing this Scalification of Java. Right? How many of you have used the Java 8 Stream API? Yeah, folks, you've already been exposed to Java, or Scala. Those, Those concepts around streams and so forth are something that functional guys, Scala guys, have been touting for years. As a matter of fact, Brian Getz, the Java language architect, he looked very specifically at the Scala syntax when he was trying to decide how best to represent function literals in Java. Specifically, do we do the single hyphen arrow or the double equal sign arrow, right? Because he wanted to see kind of which one was more popular with programmers, etc. So Oracle is definitely watching what's going on with Scala and Groovy and Kotlin and all these other languages. And quite frankly, they're going to selectively cherry pick the features that make the most sense for Java. But will Oracle buy Scala? Probably not. I wouldn't make that bet personally. If I'm wrong, then you get to say I told you so at Voxxed Vienna 2018 or whenever it is. But I don't think that's going to happen in the meantime. And that's okay. I mean, quite frankly, that's part of what this ecosystem is supposed to do, is let lots of people do lots of different things. And, you know, if it's popular, great. And if it gets popular enough, Oracle may regret it and decide to buy them later. I don't know. We'll see. Last question. Going once. Going twice. You waited until the very... I was so ready to say, it's all his fault, guys. What is it? Have I checked out Kotlin? How does it compare to Scala? Kotlin is actually much more similar to Swift, Apple's programming language. In some respects, Kotlin has some functional capabilities, but Kotlin is not Scala. It was not designed as a functional language. It has some functional features, but it was not designed as a functional language. So I would still classify them as somewhat separate. But you got to remember, the Venn diagram, I mean, there's lots of overlap between all these different languages here. So if you use Kotlin and you like it, cool. I mean, no judgment intended. I learned Scala first. I've picked up Kotlin since, and if I were going to choose between the two, I would probably reach for Scala first just because that's where I have greater proficiency right now. But, you know, ask me in a year if somebody pays me to go write Kotlin code on the JVM, I'd do it in a heartbeat. I think it's a great language. Okay. Gone. Go away. Get beer. See ya.